It is 6:30 a.m. in Antioch, California. The 56-foot motor vessel SanCarlos is leaving her berth for the start of a 10-hour water sampling cruise through San Pablo Bay and the Sacramento-San Joaquin Delta. The SanCarlos is a highly sophisticated floating laboratory designed and built for the express purpose of taking water samples and analyzing water quality. Her passengers are California Department of Water Resources aquatic biologists and water quality technicians, truly a working vessel and crew. Water sampling is not new in California. Historical records reveal that in 1775 and again in 1776, a Spanish sailing vessel, the namesake of the modern SanCarlos, sailed into San Francisco Bay to take depth soundings, prepare maps, and take water samples of the bay. The Spanish sailors did not, however, enjoy the advantages of the modern instrumentation found aboard the newer SanCarlos. The regulation of Delta water quality lies with the State Water Resources Control Board. In 1971, the board adopted a resolution setting quality standards for the Delta water and ordering a continuing water quality monitoring program. Responsibility for implementing the program fell upon the California Department of Water Resources. Thus, the SanCarlos Floating Laboratory was born. The vessel was built and launched at Newport Beach Harbor in Southern California, and preliminary shakedown tests were conducted in that area. Having been certified as operational and seaworthy, the boat was piloted up the coast to her permanent base in Antioch in the Western Delta. Currently, the SanCarlos cruises the Delta channels and Sissoon Bay about 100 hours a month, measuring a wide variety of water quality conditions. Water quality is routinely monitored at 26 different sampling points, and additional 6 sites are sampled from shore with equipment carried in a van. The importance of keeping a continuous flow of good quality water in the Sacramento-San Joaquin Delta cannot be overstated, for the water has a multiplicity of uses and destinations. It irrigates the Delta Island farms, some of the richest and most productive land in the world. It is the nursery for striped bass, shad, and many other fish. The many industries that line the banks of the Sacramento and San Joaquin rivers depend on Delta water for their operation. It is exported through the Delta Mendota and California aqueducts to cities as far south as San Diego. Along the way, numerous turnouts to local water districts furnish irrigation water to the farms of the San Joaquin Valley, traditionally some of the nation's most productive farmlands. And certainly not least, the 1,100 miles of Delta channels are a year-round mecca for water recreationists. Aided by the rapid advance in other sciences, notably electronics and chemistry, water quality analysis has become a highly refined art in its own right. On the SanCarlos, 25 water quality parameters are monitored. Some conditions are monitored automatically on a continuous basis by onboard sensors and electronic instrumentation. Other samples are dipped or pumped aboard and immediately analyzed for such items as dissolved oxygen and turbidity. Still other samples are taken aboard and preserved by freezing or other means for later detailed analysis at the Department of Water Resources lab at Bright, west of Sacramento. Dissolved oxygen is one of the more important elements monitored on a continuous basis. Without dissolved oxygen, fish and other organisms cannot live. A continuous flow of water is pumped through a pickup screen in the hull of the boat, 1 meter below the surface, and through an onboard sample tank. Here, a sensor measures the dissolved oxygen content and displays the results on a moving chart. The pH factor, or acidity-alkalinity relationship, is also continuously monitored on board. Any abrupt deviation from normal in the pH reading may indicate a trouble spot, such as an industrial waste discharge, excessive algae growth, or even agricultural drainage. When an unusual reading is found, then further and more detailed readings on other related parameters are taken to isolate the exact nature and location of the problem. Another onboard analysis is the chloride content, a major element of seawater and a component of ordinary table salt. Here, it acts as an indicator of how far seawater has invaded the delta. Since a large proportion of the delta waters are used for irrigation, the chloride content is critical. Although some hardy crops can tolerate relatively high concentrations of chlorides, others, such as fruits and berries, can withstand much less. Other criteria continuously monitored on board are turbidity, an indication of quantity of suspended particles in the water, chlorophyll levels, which relate to algae growth, water temperature, and air temperature. Wind direction and velocity are also monitored. However, not all analyses are accomplished electrically and automatically. The detection of heavy metals, for example, requires a careful hand sampling technique. The sample is hand-dipped into a clean and chemically inert plastic bottle and is preserved for later detailed analysis at Bright Laboratory. Heavy metals are normally present in such minute quantities that molecules of metal from a pump, transfer line, or hose coupling can contaminate the sample and produce a misleading result. Another manual operation is the measurement of light transmission through the water column, a factor affecting algae growth. A device called a Secchi disc is lowered into the water on the shady side of the boat to determine the depth at which it just disappears. The collecting of organisms living on the channel bottom, called benthos, requires a sample of mud to be removed from the bottom and passed through sieves to sort out the organisms. The organisms are then preserved with alcohol to be later identified at Bright Laboratory. Pesticides, such as DDT, or any of several varieties of chlorinated hydrocarbons, are among other undesirable materials monitored in delta waters. These materials are resistant to biodegradation and may remain in the food chain for extended periods of time. Because of the channel depth or remoteness of location, some sampling areas are impractical to reach by boat. As a supplement to the SanCarlos, the Department of Water Resources operates a van equipped with laboratory facilities. Most of the on-site analysis procedures performed aboard the SanCarlos may also be accomplished in the van, with the exception of continuous flow-through monitoring. Water samples requiring analyses of a more complex nature are preserved and taken to Bright Laboratory. This is the base for instrumentation and personnel to provide sophisticated water analysis throughout Northern and Central California. Bright chemists have the equipment and know-how to measure concentrations of some components in the parts per trillion range. 1 part per trillion is like detecting 1 single drop of foreign substance in the quantity of fluid carried by 530 railroad tank cars. Water samples are brought to the laboratory receiving room in chemically inert polyethylene containers and glass bottles. Each container is carefully labeled and recorded in the master log, indicating the time, place, and depth of the sample. They are then stored according to the type of analysis required. Samples of chlorophyll, for example, arrive frozen and must remain so until analysis has begun. Other analyses, such as suspended solids and silica content, require refrigeration but need not be frozen. Still others may be stored at normal room temperature. The samples are then assigned to chemists on a priority basis for analysis. Water quality chemistry today is much more than multicolored solutions being stirred in bottles. It involves state-of-the-art developments in electronics, physics, radiation bombardment, microscopy, and macroscopy, to name only a few. On occasions where unusual trouble areas in the water system are detected, the samples go directly from the receiving room to the laboratory bench. In such expedite situations, analysis reports are often returned to the requesting agency on a 24-hour turnaround basis. Laboratory personnel frequently work long hours to accomplish this. What, then, is the final return from all this comprehensive effort? Although difficult to assess in numbers, invaluable guidance is furnished to the many agencies responsible for providing usable water to the consumer. Water quality deterioration may occur from many causes. Sometimes it is the result of human error or carelessness. In other cases, it may be a natural reaction to a combination of influences such as tidal and channel flow, water temperature, and climatic conditions. When water quality problems do occur within a particular area, the monitoring program identifies them so that remedial action may be taken. Such action, depending on the nature of the problem, may be as simple as increasing releases from upstream reservoirs for a few days. Or it might involve construction of a temporary barrier dam to alter the direction of channel flow. Another and much longer-term result might be court injunctions obtained by the regional water quality control boards against those guilty of discharging pollutants into the water. Whatever the cause and wherever the problem, the Department of Water Resources monitoring team will be on hand to examine and analyze it. The end product is hopefully to assure that the California Delta will continue to provide California with a high-quality supply of one of life's vital needs: water.